So this is a quick introduction video on vectors. So let's see.
So first, let's look at what is a vector quantity. So a vector quantity is a physical quantity, of course, which has both magnitude and direction, right? So direction here is the key because magnitude is well common for both scalar and vector. Let's make it as C. So direction is like the distinguisher of vector quantities when compared to scalar quantities. So to give a slightly more tangible example, let's take this car. This car, let's say, it's going this direction 50 kilometers per hour. So if I just give you this 50 kilometers per hour, you'll not know where it is going to, the direction it is heading in, right? But this arrow here, it indicates it's going in this direction. So this is the distinguishing factor of a vector quantity. So this is direction here. This is the most important and basically what makes it a vector. So now that you understood what a vector quantity is, let's see general points of vector quantities. So first, let's look at vector notation. So vector notation is, well, how you annotate a vector. So if I just say 5 newtons, I don't know which direction it is going in, right? So we need to, of course, specify it's a vector first to say, hey, this is a vector, and then say direction it's going in. For example, I'll take this right path here. So this 5 newtons is going right. So this 5 newton is the magnitude. This indicates it's a vector, and this is the direction, right? So we represent a force A as a vector quantity by just doing A and on top of that a right facing arrow. Okay? So now let's see representation by graphical means. So you've seen that this A force is a vector now because of this arrow right here. Now, if I want to say in which direction it is going in, I can say an arrow like this, which this is the head. This head right here indicates the direction of the force being applied. And the tail, we can assume like the origin of where it is starting from. This is the tail. So this is unique property of vectors, that is being able to shift them parallelly. So let's take a box here. This is having a force like this of say force A, and it's a vector quantity, and a force like this, force P, vector quantity. Right now I'll just say there are two forces acting upon it. One is like this with A magnitude, and sorry, this B magnitude, my bad, okay? And then there's another force acting on it in this direction with A magnitude, right? So how do I know if I need to calculate which direction the object is to move? I need to know the direction of forces acting on it and at some place where both forces meet. So this is the part where you can, well, parallelly shift the vectors. So right here, I have my B vector, okay, and my A vector. This guy, I can move right here and make it look something like this. B vector, A vector. So this is where the tails meet. And you must remember, tails should always meet while joining vectors, that is, while parallelly shifting vectors. Tails should meet. So now that you've seen how these, well, vectors are joined and parallelly shifted, now let's see the angle between the vectors and which angle to consider and all those stuff. So again, I have a vector A and a vector B. I'll just shift them to get vector B like this and vector A like this. Okay, so now that we have this guy right here, the tails merging, of course. So we have two vectors here. There are two angles formed, right? So this acute angle and this bigger angle. So the question comes here, which angle to consider while calculating for these vectors, right? So you must always use the smaller angle. This guy here is a smaller angle, and yes, you use it. So here comes to major questions. What if it is 180 degrees? So that's vector A like this, and let's say the tail here, vector B like this, and this is 180. So of course, this part will also become 180. So which to consider? Since both are equal, just consider any one of the angles. There you go. So these are called opposite vectors because they're well going opposite to each other. And then now we have another type of vector where, well, the angle is 0. So there is this vector, and let me just put another color. Okay, and another vector on top of that vector, right? So let's change another color, and there is this angle which is 0 degrees, and this angle which is 360 degrees. So again, we compare these two numbers and see which is greater. So of course, 360 is greater and 0 is smaller. So we consider 0 because 0 degrees is, well, the smallest here in these two angles. So these are called collinear vectors. The next video I'll be talking about the types of vectors. So stay tuned.
So hope you enjoyed the brief explanation on vectors. Stay tuned for the next video on types of vectors. Thank you.